What happens to matter that falls into a black hole? It begins a one-way descent into a region where space and time are warped toward their limits. This process starts with the bending of light and ends at a point where the current understanding of reality breaks down. The process begins with an object far from the black hole, where its gravity is similar to that of a normal star. From this distance, the black hole appears as a sphere of apparent blackness, a circular void in the starry background. The light from distant stars that passes near its edge is visibly bent, creating a distorted, warped view of the cosmos. This region of gravitational influence is an early sign of the unusual physics that lie ahead. As an object descends, it approaches the event horizon. This is described not as a physical surface, but as a point of no return. For an outside observer, the falling object's motion would appear to slow as it gets closer. It would seem to take an infinite amount of time to reach the edge, its image becoming redder and dimmer until it fades from view. For the object actually falling, however, nothing would seem to happen at the event horizon itself. According to relativity, it would pass through this invisible boundary in a finite time. After crossing, the change appears to be irreversible. The pull of gravity is now so strong that no speed is fast enough to escape, not even the speed of light. Inside the event horizon, the warping of spacetime becomes pronounced. The singularity at the center is no longer described as a place in space. It has become a future event in time. Just as an object on Earth cannot avoid moving into the future, an object inside the event horizon cannot avoid the singularity. Available paths now converge on the center. As the descent toward the singularity continues, the force of gravity intensifies. The gravitational pull on the part of an object closer to the singularity becomes much stronger than the pull on the part far away. This difference in gravitational force, known as the tidal force, would begin to stretch the object vertically. This process, called spaghettification, would become extremely powerful. The tidal forces would stretch any object longer and thinner, while compressing it from the sides. Eventually, this stretching force would become stronger than the forces holding the object's atoms together. At this point, any complex object would be torn apart into a stream of its constituent particles. The end point of this process is the singularity itself. Here, at the center of the black hole, the current understanding of physics breaks down. General relativity predicts a point of infinite density and zero volume, a place where space and time cease to exist in a familiar sense. What actually happens at this point is a deep unknown, a question for a future theory of quantum gravity. The descent into a black hole is a process governed by high-gravity physics. It begins with the bending of light, proceeds through a point of no return, and ends with the deconstruction of matter by tidal forces. While the final moments at the singularity remain a mystery, the process reveals the strange and counterintuitive nature of gravity in such environments in the universe.